Don't say to me, Mrs. Ford, this is boring, we already did it. We're going to do it 3 times. So then, if you mess it up, I can just look at you and say, we did it 3 times.
Yeah,
right?
Understandable.
So here we go. Oh shoot, I just erased our equation. Our equation was, I have it in a box, negative 16t squared plus 20t plus 30. That's the equation that we just built to use in the rest of the problems, okay? When does the ball hit the ground? Now you're using this equation. You're going to put a number in here or in here for the t's. If the ball is on the ground, what do I know?
0.
Height is 0. Height is 0. Not time, height is 0. Alright, so for problem B, is everybody okay with putting that 0 in there? Okay. Now what? Quadratic formula. Now, you are free to do the quadratic formula right now. You have a calculator that will help you with these big numbers. You might also notice, though, that all of these are divisible by 2.
Yes.
So if you want your numbers to be a little smaller, you could divide everything by 2. You do not have to. And in fact, I'm not going to this time. Normally I do because I like smaller numbers. It doesn't make any difference, so I'm just going to go ahead and use these numbers. So, t equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay? Is that all right with everybody? So now, luckily, I have a calculator that will help me, do stuff. So negative, 400. Underneath there, I got 2320.
Oh, I put it in the wrong number. I missed the 0 on the board.
So I got negative 20 plus or minus 2320. 2320 over negative 32.
Yes.
Now remember, that's actually 2 numbers. It's negative 20 plus the square root of 2320 over negative 32. And it's negative 20 minus the square root of 2320 over negative 32. Now, keep in mind that you're solving for t, right? So look carefully at these answers. Negative 20 plus the square root of 2320 equals divided by negative 32. Uh-oh, I got negative 0.88. Tell me about that.
Can't be negative.
T can't be negative. So whatever that answer is no good. I'm going to throw that one out. If you didn't get negative 0.88, make sure that when you type in negative 20 plus the square root of 2320, you're hitting equals or enter. And then divided by negative 32. Ellen?
So I actually simplified that like radical inverse and then got a different answer.
No, there's only one answer, so either you're wrong or I'm wrong.
Okay.
Simplifying it is fine, but I would just say this, Ellie, if I'm going to my calculator, it doesn't make any difference. What did you simplify that to?
4 square root of 290.
Okay, that's not right. So 2320 is 2 times 2 times 580, which is 2 times 2 times 2 times 290. So it's You want to pull out 1, 2. So it should be 2 times the square root of 580. But again, I would not waste my time doing that if I'm going to my calculator. All right, negative 20 minus the square root of 2320 equals, divided by negative 32. I got 2.13 on that one.
Yep.
So the question is, when does the ball back on the ground? And the answer is 2.13 seconds, after 2.13 seconds. This answer didn't make sense. We didn't make any mistakes. It's just an extraneous root. Time cannot be negative. For that matter, could h be negative? No, we don't want any negatives in this problem, right? All right, last question. Go back to your equation, this same equation you've been using. How high is the ball after 1.5 seconds? Now, Roxy, we gotta do something with the 1.5. It's gonna go into this equation somewhere. Where's it gonna go? T. Absolutely. Why is it going in for T? Because it's a time. 1.5 seconds. So I'm going to do negative 16 times 1.5 squared plus 20 times 1.5 plus 30. You can use your calculator, but just make sure you're doing things in the right order. What has to happen first here? PEMDAS. What has to happen first? Well, exponents, right? There's really nothing to do inside there, but I do need to square. So 1.5 squared, 1.5 squared, times negative 16. So I got negative 36 here. Did you? Negative 36?
Yes.
All right, and then 20 times 1.5, I got 30. And then plus 30. So is that, what is that? 24?
Yep.
How high is the ball after 1.5 seconds? 24 feet. So I know it's been spread over 2 days, but all that time that we've done, that's the whole test. We just did the test, all right? So now we're gonna look at practice test 2. And you will notice it looks very, very similar. So here we go. Practice test 2. Which property is shown? Have you studied your properties yet? If not, remember you have extra practice in Schoology with answers, full page of it. You can practice. What property is A? Additive inverse. Additive inverse. So you can abbreviate, but you gotta have the addition part and you gotta have the inverse part in there. It's the additive inverse. All right, look carefully at B. Any brave soul want to take a wild guess what B is, Olivia?
Isn't addition associative?
It is associative of addition. That is exactly right. Why is that associative, Olivia?
Because we still have the same numbers, but parentheses are in different order.
They're not in, the parentheses are moved. Yes, the grouping is different. So it's the associative property of addition because the numbers themselves haven't moved. Only the parentheses have moved, right? When that happens, when the numbers don't move, just the parentheses, it's associative. All right, and then how about C? Close, it's the multiplicative inverse. When things cancel out, Michael, pull your mask up, please. Gabe, open your eyes, thank you. When things cancel out, When things cancel out, it's the inverse. So they cancel out in A and they cancel out in C. One is addition, one is multiplication. All right, 2A, solve. What are you going to do with a problem like 2A? So it's quadratic, and I heard somebody say, is it factorable? I don't know, it might be, right? I'd have to play around with it to see. But if I don't want to play around with it, or if it's not factorable, what can I always do with the quadratic? The quadratic formula. So some of you are just naturally going to do that because you don't like factoring. So I'll just go ahead and do the quadratic formula. Negative b, watch it. B is negative 1, right? That's going to be 1. Oh, this one does factor, but that's okay. That's all right. All right, what's under the radical? Watch the negative signs. Make sure you're keeping track of all that. I got 49. And that's how I knew it factored, because 49 is a perfect square. So I'm going to get 1 plus or minus 7. And when that happens, you know you could have factored when you lose your radical. But that's okay. I'm going to get the same two answers. What am I going to get? 1 plus 7, 8 over 12. And 1 minus 7, negative 6 over 12. You see what I'm doing? 1 plus 7, 1 minus 7. Now I got to reduce these. 8 twelfths reduces to 2/3. 4 goes into both. And this reduces to negative 1/2. So those are the answers to the problem. If you would have factored, your factors would have been 3x minus 2 and 2x plus 1. That should, yeah. Those would be the factors if you factored it. But again, it makes no difference. This is perfectly fine. See where the directions say show all work? That's all that matters to me, is show me how you did it. All right, good on that? Oh no.
I'm sorry, my mom said.
You know what? I'm a mother. I love being a mother. I love your mother, but not during class. Okay?
Yes.
That'll be one of the detention things, okay? Don't do it again. My list is getting along today. All right, here we go. Almost gave away a bonus point though. All right, what do I do here? Again, you do it however you want. I'm going to do it on the number line. And right in the middle of the number line, I'm going to put the opposite of the middle number in the problem. So the middle number in the problem, it's plus 2, so I'm going to put negative 2 here.
Yes.
That's my starting point. Now, I'm going to count this way and put a dot, and this way and put a dot. And I'm going to count this many. So if I go add 7, I'm at 5. And if I back up 7, I'm at negative 9. So my dots are at negative 9 and 5. So with 2 dots, I'm always going to shade between them or outside of them. Which way is it? I'm going to shade out. Why am I going to shade out? Greater than. So as an interval, I got to remember this is negative infinity. So negative infinity, negative 9. right there. And then 5 and positive infinity. Ellie?
Could you do it as like if x is like less than -9 and then like greater than 5?
Unless the directions say right in interval notation, and I'm kind of pushing you in that direction because that's how we do it in calculus class. So I would prefer you do it in interval notation.
Okay.
But yes, it says the same thing. It means the same thing.
I'm still kind of confused. I'm like, how do you know when to put the brackets?
Somebody helping. How do we know there's no brackets in this problem? Michael?
If it's greater than or equal to.
Exactly. And that comes from this right here, right? Infinities, no matter what though, infinities are always parentheses, no matter what's going on in the problem.
If we're writing it in the like for form, why don't we do the alternating form? Oh wait, actually
It does alternate. Shade, no shade, shade. There's 3 sections there. The 2 is not really, that's not a section divided, the dots divided up into sections. So it does alternate. Yep. So you could do it that way too. All right. Next. What are you going to do with problem C?
I'm gonna go by 24 because
I would multiply the whole shebang by something. What you multiply by doesn't really matter as long as it cancels out all the denominators. So there are lots of things you can multiply by. What's one thing we could multiply by that would cancel both of these denominators? 12? Could I also multiply by 24? Yeah. Don't think there's only one number. Multiply by anything that will cancel the denominator. So if you say 12, what will happen with the 12? The 4 will go into the 12 and leave a 3, right? And now that's gone. Then this one by 12, because I got to do it all by 12. This will be gone and leave me with a 2. All right, so I have 6x minus 3. Remember, 4 went into 12 3 times, and I'm distributing, plus 2x minus 4 equals 24. I gave a quiz this morning, a makeup quiz to some kids, and they missed this problem because they forgot to multiply on this side. You got to multiply everything by 12, or 24, or whatever you're multiplying by. All right, I got 8x minus 7 over here, if I added right. And 8x equals 31, I got 31/8. I do not put that on a number line because it's an equals problem. Equals problems don't have shading, right? They just have equals. That didn't seem too bad. Where's the hard problem? Oh, it's coming. It's coming. All right, part 3, some more things to solve. This one is an inequality. So I will draw a number line and be ready. I'm going to have some dots on the number line here. And I have to figure out where those dots are. Look at that problem. What do you think about dots? Where do you think the dots will be? Or how will I figure that out? What do you want to do?
No,
Chuck, you awake today?
Yeah.
All right. What do you think? Factor it? This one factors way easier than the other one did. But what if I don't know how to factor, or I'm just not good at factoring, or it scares me and I just don't want to do it? I can always use the quadratic formula. Now it's going to take longer, but you can always do it. Where will the dots be on my number line now? This tells me at 1 and 4. This time, Gabe, the dots are going to be colored in. which means I will be using brackets for the 1 and the 4. Now, because it's an inequality, I have to do some shading. When I have 2 dots on my number line, and it's a less than, where do I shade? Inside. Right? Less than, smaller than, skinnier, fatter, skinny. So my answer, in a problem like that, Ellie, I think it's easier to write it in interval notation than any other way. All right, Sean, you got that? What can we always do if Mrs. Ford's motoring through and we kind of got lost or missed something? What can we always do? Go back and watch the video. Always, right? You can pause me. I don't know, can you slow it down? I don't know.
You can slow it down, maybe.
I don't know. You can fast forward through the parts you don't want. All right, next, what do we do here? Square both sides. This should be an easy one for you. X minus 2 equals 25.
Yeah.
So X equals,
Oh, stupid, oh, God, I subtracted,
well, it should be easy. 27,
Yes,
easy. Now we got the doozy problem. Here's the hard one. Or maybe you don't think it's hard, I don't know. Big, what do we do?
take the other one.
Luckily, it's not a number line, so I'm not gonna be doing any shading. You said take out an X? Can I take an X out of the whole thing?
Oh, wait, no.
No, I don't think I wanna be taking out an X, right? Olivia? I'm gonna split it. Like right in half, like right here? So what comes out of this half? X squared. Leaving me with X plus 3. What comes out of this half? Negative 4 again. Now watch it. I'm taking out a negative 4. So that's going to leave me with an X plus 3. Which is great news because remember these have to match. I promise I'm not going to give you one on the test where they don't match. If yours don't match, you messed up, go back and figure it out. Now, write the match down. What's left? Oh, I think that's the same thing that was left before. What do we do with X squared minus 4? Perfect, it's the difference of squares. It will always factor into X plus, X minus. And from that, you should be able to tell me the answers. X is going to equal what? Negative 3. Remember, you're setting this equal to 0 and solving. So that would be negative 3, negative 2, and 2. No number line, no dots, no shading, no intervals. We only do that stuff when this is a less than or a greater than, right? When it's an equals, you just solve it. X equals. You all clear on that? All right, next one. Oh, this should be easy, hopefully. Simplify. Be careful. I think we talked about this yesterday. What do I do with this problem? Am I going to FOIL this?
No.
No, it's not a multiply. This is a subtract. So I'm just going to drop the parentheses by doing my distributive.
Yes.
Michael? Wake up, sunshine, you feel okay? Okay, well sit up, wake up, we're reviewing the big test coming up. And now I'm going to, let's see, collect like terms. So that would be -2 minus 3i. Did I do that right?
Yes.
And that's it. Okay. How about the last one in this section? 4 plus 3i over 2 minus 3i. What do I do with that? Multiply by the conjugate, which is 2 plus 3i. Yep.
Couldn't you cancel 3 out for both 3 hours?
Here?
Yeah.
No, because they're hooked to the pluses. If you're gonna cancel in an expression that has pluses and minuses, if you're gonna cancel in something like this, you have to be able to factor something out. You can't cancel parts, okay? So think about it like this, Olivia. 4 plus 2 over, obviously 6 plus 2. That would be 6 over 8. Would you agree with me? Well, if you cancel these out, you would be left with, well, either 4 over 6, or if you made these ones, you'd be left with 5 over 7. Are those the same thing? No. Once you put a plus sign in there or a minus sign, the only way you can cancel is if you can factor. So if you could factor a 3 out, you can cancel it. Otherwise, do not cancel. All right, anybody got this foiled for me yet? 8 plus, you're ahead of me, 12i plus 6i plus 9i squared. I'm foiling on the top and on the bottom. What about I squared? So that'll be -9. And this one will be +9. Please don't cancel them, we're gonna combine them. So 8 minus 9 is -1, plus 18i, and 13 on the bottom. Who has a question about that, anybody? All right, I guess we're ready for number 5, which is another exponent problem. So, Chloe, when you look at this exponent problem, got stuff to do here for sure. What occurs to you? What would you like to do first?
Go for
All right, so she says, I want to cancel the 4 and the 12. Now hang on to the X's, because they're a whole different ballgame. But the 4 and the X, or the 4 and the 12, do cancel in 1 and 3? Done. All right, Avery, what would you like to do next?
cancel out the X's.
You can, because you've got 5 of them on top of 10 of them, which would leave you with 5 of them in the bottom. 10 is bigger than 5. So now those are done, we took care of that. I thought you'd do the Y's first, but you don't have to, this is fine. What happens to the Y's? This guy goes up, right? So there's 8 of them up there, and 3 more are coming up. So I have y to the 11th on top. This 1 is perfectly fine. but it isn't really necessary. So if you don't have a 1 there, it's fine. If you do have a 1 there, it's fine. All right, we're gonna do, I think, one more problem. That's all we have time for here. You're all just fried. I don't know what you ate for lunch, but whatever it was, it wiped you out. All right, write the equation of the circle whose center is 2, -1, and the radius is 5. Now, I know there's space there to show work, but there isn't any work to show. You can just fill in the answer blank right now. What does that equation look like?
X minus 2 squared.
X minus 2 squared. Foster, are you paying attention back there?
Yeah.
X minus 2 squared plus y plus 1 squared equals 25, because this is always your r squared. Campbell?
Does it matter what order you put the parentheses in?
You mean, could you have the y first? You could, as long as the 1 has to be paired with the y. But yeah, no, these can be switched around. Yeah, they usually aren't, but you could, wouldn't hurt anything to do that.
Oh, so it doesn't matter if you switch it.
Not the order of the parentheses, but you gotta have 2 with the x and 1
Yeah,
with the y.
yeah, I know that because I was doing the problem before and then I switched it.
Yeah, no, that would be fine.
Right.
All right,